Ladies and gentlemen, so we make progress with integration. So today we're going to do definite integral and area under a curve. So what's this? So under definite integral, to find the area under the curve, maybe let's say you have been given the area under a given curve y is equal to f of x. This can be computed by using definite integral. That is, so this is the formula that we use. Area is equal to integral as a approaches b, f of x dx. So f of x is the function you have been given, which you are supposed to do what to integrate. So where b is the upper limit, so this b here we call it the upper limit, then and a is the lower limit. So let's dive into some examples for you to fully understand how we go about with the area. So this is definite integral. So question 1 says find the area under the following functions. Now, question A, integral as 1 approaches 3x plus, then x plus 2 dx. So what are we supposed to do first of all? We first have to integrate this function here. So how do we integrate? Is equal to, so we do this. So x plus 2, what's the integration of x plus 2? It will be x 1 plus 1 over 1 plus 1 plus 2x. Since 2 here was a constant, 2, you only have to make it 2x, that's all. Then here you put a 3 here, a 1 here, then is equal to, which is this. So x 1 plus 1 is 2 over 2 plus 2x here. Just put it like this. Then so let me write it properly. Open x squared over 2 plus 2x 3 1 here. So whenever you have these two, what you do is you replace both of them in the function. Where there is x, you're putting these two. So how do you put them? So for the upper limit, it will be the first one. You get this entire function. Where there is x, you put the upper limit minus the same function. Where there is x, you put the lower limit. So let's do what we're talking about here. Is equal to, so it's 3 squared over 2 plus 2 multiplied by 3 minus 1 squared over 2 plus 2 multiplied by 1. So which is equal to, what's 3 squared? It's 9 over 2 plus 2 multiplied by 3, it's 6 minus 1 over 2 minus 2 here. So is equal to, so even if we can even make it out from here. So since 2 is the denominator on both sides, so you make a 2 the common denominator for everything. So 2 into 2, it's 2. 2 times, 2 into 2, it's 1. 1 times 9, it's 9 plus 1 into 2, it's 2. 2 multiplied by 6, it's 12 here, minus 2 into 2, it's 2. So you have a 1 here. 1 into 2, it's 2. 2 multiplied by 2, it's negative 4 here, is equal to. So what's 9 plus 12? Oh, okay, let's just compute it together. Okay, step by step. 9 plus 12, it's 21 minus 1 plus 4, it's 5 here. So 21 minus 5 over 2. So the final answer is given 21 minus 5, which is 16 over 2. So the final answer is 8 here. That's the area under the curve. It means you are done from here. Then we now go to our example 2. So we're finding the area of integral as 0.2 approaches 1 of x squared plus 1 over x dx. So what are we going to do? So it's equal to So we'll do integral x squared plus 1 over x dx here, then 1 0.2 here is equal to, so we are first integrating this function here, so you have, so it's x 2 plus 1 when you integrate x squared over 2 plus 1 plus integration of 1 over x. Under the standard results of integration, we said the answer is in x. So here we just introduce the magnitude here, dx. Oh, dx has disappeared already, so it's 1 0.2 here, so is equal to x, what's 2 plus 1? It's 3 over 3 plus in magnitude of x 1 0.2. So what are we going to do now from here? We said we'll start with the upper limit. So the upper limit here, we'll get it and substitute it where there is x. We'll substitute it in this equation minus this one substituted in this same equation, so which is equal to, it's 1 over 3, so you have a cubic here, plus in modulus of 1 minus 0.2 to the power 3 over 3 plus in 0.2, so which is equal to 1 to the power 3, it's 1 over 3 plus natural logarithm of modulus of 1, it's 0, minus 0.2 to the power 3, it's 0.008 over 3. So when you punch this on your calculator, it will give you negative 1.61 multiplied by this negative, which will be positive 1.61 is equal to. So now punching all this on your calculator, when you get your calculator, the final answer it will give you is 1.94. You are done. That's what area of integration deals all about. So they are very simple and straightforward. There's nothing, as long as you know just how to integrate a function, you're good to go.